Ist alles bereit für die Mars mission? I'll now switch in English. This is right? Yep. Yeah, you will have this talk in English. So I'm really glad to introduce you Rin Räuber and her interest in Mars missions and her expertise, how we will settle on Mars and why. Because what seems almost impossible is just what we need. Rin Räuber, she is a blogger and describes herself as a wannabe cyborg, but I found out she really is a cyborg, a magnet in her fingertip, an ID chip in her hand, really. I'm not joking. And yeah, of course, a really enthusiastic Mars fan and coder, so maybe she will make it real.
Okay, does this work? Awesome. Anecdotal evidence that I'm really enthusiastic about Mars. I was at stage for like yesterday night. Who else was here? Yeah. And so I woke up, like, of course, first with a hangover and with 3 awesome guys, but still, I left my bed to go here and give this talk, so it seems I'm really enthusiastic about this. So I hope I can share some of this enthusiasm with you. That's a picture of the Martian sunset taken by Spirit in 2005. Why you should listen to me in the next 30 minutes is it's a really good time to get excited about Mars. And I'll tell you why later. And I got some pretty pictures. Yeah. So I checked the weather on Mars today. I'm not really sure if this is, this data might be 2 days old, but let's ignore that. Like, the temperature is minus 21 degrees. That's a little cold, but those of you who live in Berlin can handle that, I guess. And that's just like a little preview about the pretty pictures. Like this dot here is actually Curiosity, and this picture was taken by the Mars Reconnaissance Orbiter on Valentine's Day this year. So, why should we go to Mars? And this is my most difficult slide because it sounds really lame, but because of inspiration and do something that was deemed pretty much impossible, and that still sounds close to impossible today. Yeah. So that's rock. You know geology, right? Like the stuff where you look at rocks. And to be honest, for me, geology is not really interesting. Rocks, seriously. But now imagine that this rock might be fucking 4 billion years old, and it might be from a different planet. And that's a whole new level of interesting, right? And this shows one of the interesting geological features of Mars. They are called galleys. They are like 1 to 10 meters wide and were discovered in 1999 by the Mars Global Surveyor. And the interesting thing is, like, you can find similar features on Earth, and usually these have to do something with liquid water. So that's an animation taken from spring of one Mars year to the summer of the next Mars year. And you can see like these dark markings appear. Yeah, they are called recurring slope linear, or RSL, if you're really cool and you know Mars speak. Like they appear in warm seasons and then they disappear when it's cold. And there are a lot of theories about what these are, but of course one theory is that liquid water is involved in the appearance of these, and that's just one of many unsolved mysteries about Mars. Like another one of these mysteries is we now know that Mars had conditions suitable for life in the past. Like it had flowing water, maybe even oceans, maybe planet-scale oceans like we have, and probably a thicker atmosphere. So one question is, why is Mars like this pretty much dead desert now, while Earth is alive? And yeah, so that's another reason to go to Mars, is just curiosity, and not talking about the rover here. Okay, 50 years ago, there were these people who wanted to fly a rocket to the moon and land it there and not kill everybody in the process. So if you want to do that, your main problem is navigation. So the guys asked the people at MIT, and MIT were like, you know, there are these things called computers, and you should totally use one of these. But as we all know, back in the 60s, computers were these huge things taking up rooms. But there was this thing called an integrated circuit, and some companies were actually experimenting with it. So NASA was like, okay, let's get a few of these and build a computer. And yeah, I think they needed like some thousand, but they just ordered 1 million just to make sure that the manufacturer could make them and to test them, and yeah. So this made NASA the largest single consumer of integrated circuits in the 1960s. And that's another reason, like, because, I mean, NASA didn't invent the integrated circuit, but they pretty much kickstarted this technology. Because, of course, when you want to do crazy stuff like go to Moon or go to Mars, and you can't do it with existing technology, yeah. So everybody's always complaining about how they were promised jetpacks and flying cars in the future that is our present now. But, I mean, fuck flying cars, let's go to Mars instead, right? This is a pretty sad slide, and I would actually love to not mention this at all. But the success rate for missions to Mars is less than 50%. So the red part is failed missions, and the green is successful missions. And like the little orange slice is 2 missions that are on their way at the moment. Okay, but the good news is it's getting better. So this is a little unfair because, of course, the first 10 missions, of course, almost all of them failed. And then there's like the fact that the distance to Mars is 92 million kilometers. Oh no, actually, I mean, that was April the 14th of this year when Mars was really close to Earth. And like, usually when Mars is not really close, it's more like 400 million fucking kilometers. So that's a lot. It took Curiosity 250 days to get to Mars. And hopefully it will take a human crew only 180 days. But still, that's 180 days of zero gravity, solar storms, radiation, cabin fever, and stuff breaking. And like this distance also means that the communication might take up to 40 minutes. So something might go really wrong, and it will take 40 minutes until like ground control or whatever, mission control, will know about it. Yeah, so going to Mars is a huge endeavor, and compared to that, like something already awesome as ISS is just car camping in space because everything's nearby. You've got only 2 days of transit time. You've got almost real-time communications, and yeah. So, but like all these difficulties, I just made this another reason. So, JFK reference here. We should go to Mars because it is hard, because fuck it. Oh yeah, like I've summed that up in one slide. This is why we should go to Mars. So before I'll tell you how we get to Mars, I will quickly talk about where we are now. There were, like, you can count, I mean, differently, but there were around 90 successful missions to Mars, like 3 flybys in the 60s, 9 orbiters, and 7 landings, 4 rovers, of which 2 are operational right now. And yeah, that's a picture of the Phoenix lander in 2008. It has got this robotic arm with this cute little shovel and like this whole big sandbox of a planet. I really like that picture. So the first landing was Viking in 1976. Like that was 38 years ago. So actually we've been on Mars for a pretty long time, I think. Yeah, now comes my awesome map, and I hope nobody from NASA or anything sees this, because I placed these on the map myself, and they're probably like some 1,000 kilometers off. But so that's Viking in, as I said, 1976. Viking 2 in September of the same year. Then there was Pathfinder and the Sojourner rover in 1997. Yeah, 20 years like after Viking. Spirit in 2004. And it's Opportunity twin. It's twin Opportunity. 3 weeks later. Then there was Phoenix, which we just saw on the slide. And finally, Curiosity. So as I said, we've got 2 operational rovers, Opportunity and Curiosity, and 3 orbiters. And most of the pictures we see are from these orbiters, like especially the Mars Reconnaissance Orbiter has an awesome camera aboard. Right. Remember how I told you that it's a good time to get excited about Mars? That's because there's a lot to look forward to. This September, 2 orbiters will reach Mars. That's the MAVEN probe by NASA, which will study the atmosphere, and an Indian Mars mission, the Mars Orbiter mission. In January 2060, ESA will launch its ExoMars orbiter, that will search for possible biosignatures of Mars on Mars. And then in March of the same year, we've got NASA's InSight lander. Okay, the InSight lander will launch, I think, in the beginning of 2060, and hopefully be on the surface at the end of 2060. Then we hopefully will have a European rover on Mars that will launch 2018, yeah. And then there's also another rover by NASA. And at the moment, they are evaluating proposals for the scientific payload for the Mars 2020 rover. So that's where we are today. So let's get on to the how. So what I'm presenting now is pretty much taken from a document by NASA called the NASA Reference Architecture version 5, and that outlines how to get people to Mars. And it's actually pretty detailed in some areas. It's around 80 pages long, and you can actually read it if you're bored. It's interesting and for the most part comprehensible. Like I skipped everything about I don't know. No, just if you're interested, look at it. Okay, to get to Mars, we first need some astronomy 101. That's the sun. The blue dot is the Earth, and the red dot is Mars. And of course, that's not accurate at all. So, as you might know, the Earth takes around, it actually takes 365 days to complete one orbit around the sun. And Mars takes twice as much. It takes 687 days. So, like when you get to Mars, there's two options. Like you call this conjunction when the two celestial bodies like align. Like this is when Mars and Earth are pretty close to each other, and when they are in opposition, they are at a pretty far distance. So if you want to get to Mars, you've got two main trajectory options. The first one is called like these are opposition class missions, where you like you start on Mars. No, yeah, that would be nice, right? Okay, you start on Earth when Earth is in opposition to Mars, and then it takes you, these number of days. Of course, they vary, like depending on when you go there. But I actually took these from an actual departure window in 2031. So, that's suppose you start, you launch to Mars June the 2nd, 2031. Then it takes you around 330 days to get to Mars. Then you stay there for 40 days. And then it takes you 308 days to get back to Earth. And that seems pretty counterintuitive, right? Because, I mean, you've got this surface stay of about, that's pretty short. It's a long holiday, but it's still pretty short. So there's the alternative. You launch when Earth and Mars are in conjunction. Then it only takes you 180 days. But then you stay there for 545 days. That's the caveat, because that's a long time away from home. And then it takes you 180 days to get back to Earth. So I think I summed that up. Like, there's this short stay mission, the opposition class mission, with the disadvantage of a very short surface stay. And also, your crew spends, most of the time in zero gravity and deep space radiation. It's not cool for the crew, and it needs a lot of energy. So, the second option, the conjunction class, needs less energy. And yeah, it just has this very long surface stay, but actually the surface stay is cooler for the crew. And this second option is ideal for cargo because, your cargo doesn't care about zero gravity and it doesn't care about radiation and it doesn't keep asking, are we there yet? So, so of course we're going for the second option. Components. These are just shapes I made up. They have nothing to do with the actual stuff, but the slides are Creative Commons, so NASA can use these if they want for their design. We need the mass transfer vehicle. Of course, NASA loves acronyms, and all sorts of abbreviations. So that's the MTV. this will get a crew of 6 to Mars and back. Then there's the ascent-descent vehicle, and that will actually get the crew to the surface of Mars and back up. And then there's the habitat where the crew will stay these 500-something days. So the blue thing is the Earth again. 2 years before the crew launches and like several months before the departure window for Mars opens, we launched some heavy lift vehicles that carry like the habitat and this descent-ascent vehicle. And actually NASA already has these awesome plans for the SLS, Space Launch System. That's a heavy launch vehicle. There's different versions. Like the first one can lift 70 tons to low Earth orbit. Yeah, I think actually I was going to say that this is much, but that's just 10 African elephants. I mean, maybe 15 if they're doing Weight Watchers, but I think that's not actually that much. And that's why you need several of these to get the stuff you want to go to Mars into low Earth orbit. So you assemble the stuff in low Earth orbit by automated rendezvous and docking, which is like an awesome chapter of its own, because you've got moving objects in space and you try to get them to dock automatically without having something explode. And after you check that everything works, everything's assembled, you send this stuff to a minimum energy transfer to Mars. That's the one that maybe takes around 350 days, which, as I said, is okay for cargo. And then 350 days later, the cargo arrives at Mars, and we separate the parts again. Like, the habitat stays in Mars orbit and waits for the crew to arrive. And the descent-ascent vehicle lands. And it has its own nuclear reactor, and that's one of the awesome ideas, I think. It has a nuclear reactor that it deploys, and this will start to produce the propellant that you need for the ascent later on, because it's kind of you can't carry all the propellant you need to get out of Mars, to get from the Mars surface to Mars orbit with you to Mars, because that would be fucking expensive. So this is going to be produced on Mars, but actually, this is one part where this NASA reference architecture document wasn't really helpful in how they do it. I'm not sure they know yet. Okay, so now we have already some infrastructure on Mars, and this DAV is producing the propellant for us to get back. We launch more rockets. Next thing is the Mars transfer vehicle, and that's also something where you need several launches and then assemble it in low Earth orbit. And then after you verify that it's operational and the infrastructure on Mars is operational too, you finally get the crew up in it and send them to Mars. And then it's 6 to 7 months and a lot of are we there yet until we are finally there. Then the crewed MTV arrives at Mars. They rendezvous with the orbiting habitat, and bam, humans on Mars. The MTV stays in orbit Oh yeah. Oh, that's the part where the fun begins, right? Yeah. Okay. That's perfect. We just landed on Mars, so that's the getting back part, and that's the Orion lander, and that's already developed. I think that's a nice part. We already have the lander to get back to Earth from Mars. Yeah. Okay, so I'm pretty sure we will go to Mars. The question is when. NASA says that it will take place in around 20 years, but maybe it will take longer. So I'm going to keep eating my vegetables so that I'm healthy and I can watch the live stream when it's there. So, okay, because I had to get out of bed today and stand here and give this talk, I've got a favor to ask. Please tell somebody about Mars and that it's possible to go there and how awesome this is. Yeah, that's my favor I want to ask you. Thanks.